Alright, this is Nomenclature by myself, Luke Martin, and Dalton Houle. Alright, so we're going to start at elements and compounds. Elements are the purest form of matter, while compounds are made up of two or more elements. So the way that you'll be able to tell if it's an element or a compound is that an element will only have one capital letter in it, like how you see capital A, lowercase g, capital N, lowercase a, and so on. And then how you see things like ammonium having a capital N and a capital H, and then carbate having a capital C and a capital O. As you'll note, oxygen has a little 2 over there. That doesn't mean that it's not an element, it just means that it's diatomic, and we'll get to that later.
Okay, so the three types of elements. We have metals, nonmetals, and metalloids. Metals are typically found in what we know as the S block, D block, and F block. S block's right here in this 2 rows. D block is right in the middle, and the F is down here. And then the P block is where the steelers, or the nonmetals and metalloids, are located. Nonmetals are found to the right of transition line, which is located right about here, and the metalloids are found on the transition line. Metals are typically known as the losers of the periodic table because their ion versions have a positive charge, which means that they lose electrons. And stealers, or the nonmetals, are typically known as the stealers because their ion versions have negative charges and try to get to 8 valence electrons by stealing from the metals. And a little more on that, what Ben was saying, monatomic and diatomic elements. Monatomic elements just means that if an element is monatomic, the most stable version of itself is when it's bonded with itself, or not bonded with itself, when it's alone. These consist of metals, metalloids, and some nonmetals, but mostly, most of them are diatomic, which means that they're most stable when they're bonded itself, and there's only 7. There's hydrogen, nitrogen, oxygen, iodine, chlorine, fluorine, and bromine. And an easy way to memorize this, I forgot my mark. An easy way to memorize this is the genuine method. So you write the word genuine with a little dash in the middle. And to memorize it, any element that ends in gen, like hydrogen, nitrogen, oxygen, is diatomic, and then, or this is for nonmetals. And any nonmetal that ends in ine or ene, like iodine, chlorine, fluorine, is diatomic as well. And then just real quick, to name these elements, you don't have to memorize the whole periodic table, you can just look at one. If you're in Ms. Falvani's room, you have one up there, and you should have one.
Okay, so there are 3 types of compounds. First, you have ionic compounds, which means the atoms are exchanged. Then there are covalent compounds, which means the atoms are shared. There's a third type between 2 metals, and it's called metallic bond, but no compound is formed. So every compound has its own set of rules when it comes to naming and forming. So when it comes to covalent compounds, it's between 2 nonmetals. When it comes to ionic compounds, it's between a cation and an anion, and electrons are transferred from a metal to a nonmetal. And for metallic, it's just a bond, but it's between metals, and valence electrons form a C around positive metal cations. So in order to identify whether it's covalent or ionic, you're going to look at the name of each element. So you see lithium and chloride. So you locate where lithium is. You see that it's in the metal section here. So that's a metal. And then chloride, it's over here in the nonmetals. So that means it's going to be an ionic compound. Here's another example. Here's fluorine and fluorine chloride. So you're going to look for fluorine. So you're going to see that it's a nonmetal. Then you're going to look for chloride and see it's also a nonmetal, and you're going to see that it's covalent. So going for formula to just to figure it out, so you locate where the symbols are. So LiCl, you're going to see that lithium's here, chloride's here. It's going to be ionic compound because that's a metal and nonmetal. And fluoride, or fluorine and chloride, and you're going to see that they're both nonmetals, which means it's going to be covalent.
Okay. How to name all types of ionic compounds. So they can come in multiple different forms, with multiple different types of ions. monatomic, which is when it's a single atom ion, polyatomic when it's multiple atoms forming an ion, and then with transition metals. Using this model on the right, which I'll go on later with example problems, you'll see that it's easy to find the formula for the name and name for the formula. Just note that there's 3 exceptions when you're using or doing a problem with transition metals. Zinc and cadmium will always have a charge of 2, so you don't need to write zinc 2 as a Roman numeral. And silver will always have a charge of +1. Some quick rules before I get into some problems. Monatomic ions, you must always write the cation first for the formula and name, and always drop the ion ending. Like here, platinum 4, it'll be platinum 4 ion and oxide ion. Just drop those and combine them for the name. And then for polyatomic ions, never combine the subscript when crisscrossing, and I'll get into that in a second. And also follow the same rules as monatomic ions. And then with transition metals, the charge of the metal is represented by a Roman numeral, except for 3 exceptions. And then determine the numeral when naming before the crisscross method. Don't get confused. So here's a quick example of the crisscross method. I also used it in another example, some work examples. We have platinum 4 and oxide. And so, platinum 4 means that has a charge of 4, and oxide has a charge of -2. And so you want to crisscross them and put 4 as oxygen subscript and -2 as platinum, or not negative, but 2. And so you have PT2 or platinum 2, ox O4. And then you see that this can be simplified using the GCF because 2 can go into each. So you end up simplifying and get platinum 2 or PT2 O2. And then here are some examples. So first we start off with KCl. And in order to work from there, you want to identify the cation and the anion. In this case, the cation would be K, and then the anion would be chlorine. And then you just combine them. It's as simple as that. It's a pretty easy one. Okay. And then for this example, we have 2 polyatomic ions. And we're going to start with the name this time. So here we have ammonium carbonate. You want to identify each of them and their formula. So you have ammonium separated as a cation because it's written first. And then you're going to need to look up or use a sheet to figure out that the formula for ammonium is NH4 + 1. And same thing with carbonate. Carbonate is CO3 - 2. And then you want to use the crisscross method here. So you put 1 as a subscript for carbonate and 2 as a subscript for ammonium. And then make sure not to combine subscripts, which I was talking about earlier. Write ammonium or NH4 in parentheses, and then put the subscript after it. And then when you have 1, you don't need to write subscript, so you have CO3. And then here, one more example. Going from the formula to the name this time, we have TiS2. This one's a little harder because when you look at the periodic table, you know that sulfide has a charge of -2, and that titanium can have multiple different charges. But once you work backwards, you can figure it out. So if you have TiS2, you put the subscripts with the element. Just try to find its original. So if you have Ti2 and S1, you know it's not right because S has 2. So you want to change this to 2, and then you realize to unsimplify it that titanium is 4. And so with Ti4 and S2, you can find out that it's originally titanium 4, right over there, and then sulfide is the anion. And then you just want to combine them and write titanium first because it's the cation, and then sulfide next because it's the anion.
Alright, acids. So acids are substances that give off hydrogen ions when they're dissolved or placed in water. To name the acid, you want to take the ion's name and place it before the ending or the suffix, and depending on if it ends in "ide", then you want to add the hydro prefix before it, and then for all of them, you want to make sure that you add acid to the end of its name. So here are some examples or guidelines. For ions that end in "ate" and "ide", you want to replace both of those with "ic". Ions that end in "ite", you want to replace them with "us", and then you want to make sure that The only thing differentiating the ending on these or the names of these is adding the hydro prefix to the "ide." So, for example, chloride would become hydrochloric acid because you add the hydro there because it initially ended in "ide," and the "ic" because it also initially ended in "ide." But you'll notice that in things like phosphate, you only take away the "ate" and add the "ic" to make the phosphoric acid, and there's no hydro there because it's not "ide." And then for nitrite, you want to just take away the "ite" and add the "us" for nitrous acid. It's important too that when writing these, they do have an H in front of them. So for chloride, it'd be HCl. That's important to have the H there when writing them out. And then for phosphate, just for an example, you want to make sure that their charges also match. So we know that phosphate has a charge of -3, and then so you want to make sure that that also matches that charge, and then you want to put P4 there, and that's how you write them down.
Next thing we're going to talk about here is hydrates. So hydrates are just an ionic compound with water molecules stuck to it. So basic rules to follow. When it comes to making the compound, it's just the same rules as ionic compounds, but the water molecule is at the end, so it's different. And then name the water molecule using Greek prefixes here. Here's a little chart. For an example, CaO H2O3 is calcium oxygen trihydrate. It's trihydrate because if you look at this chart here, you're going to see that 3 equals tri, just like at the end there. And don't crisscross the water molecule. That's something you can't do. It's only with the ionic compound. So a little bit of practice. So you see here, you got FeCl3 times 5H2O. So you're going to write this down. So locate Fe on the periodic table. You'll see that it's iron 3. And then you're going to see Cl on the periodic table. It's going to be Cl. And then here you're going to switch the subscripts around. So then it's going to be FeCl3. And times 5H2O, which means that 5, according to this chart here, that's penta. So it's going to be iron 3 chloride, pentahydrate. Next, you have calcium oxide octahydrate. So this is going from name to formula. So if you look to your periodic table, you'll see that calcium has a charge of +2. And oxide has a charge of -2. So again, you're going to flip the subscripts here. So it's going to be calcium 2, O2. And then you can see that these are both 2, so they can both cancel out and just become 1. So it's going to be CaO. And if you see the octahydrate, you see that on this chart, octa means 8. So you're going to have times 8 H2O. So that's that one. And then for the next one, we have titanium 3 sulfide monohydrate. So if you locate titanium on the periodic table, you see it has a charge of 3. And sulfide has a charge of -2. So then here you're going to flip-flop subscripts. Then you're going to see Ti2, and then you're going to have S3. And you're going to see nana, which means 9 according to this chart. So you're going to put times 9H2O. That's hydrates.
All right, covalent compounds. All right, so a covalent compound is composed of 2 or more nonmetals, and their bond shares electrons. So they also have Greek prefixes, and they're the exact same ones as the hydrates. And one important thing to note is that when naming them, if the first element listed only has one of itself, you don't put the mono, and that only applies for the first one. When naming the second and so on elements in the compound, you want to add odd to the end and order the elements from left to right on the periodic table. So this is some practice right here. So we have SeF6, which is selenium, fluorine 6. Now you'll note the Se does only have one of itself, but like I said earlier, because it's the first one listed, we don't put mono in front of it. But because the fluorine is not first, we do want to add the hexa for the 6. So hexa. And then it's also important to replace the "-ine" with "-ide". So hexa, making it selenium hexafluoride. Now if we move on to this, which is, as you'll see, the nitrogen and the chlorine. Because there's only one of the first element, again, you don't add the mono. And then the 3 makes the tri. And the ending becomes "-ide", making nitrogen trichloride. Now, if for the next problem, I change the iodide to have, or the iodine to have, let's say 5, and then we'll keep the fluorine as 7. Then it would become the penta iodine, and then 7 becomes hepta, as we see on the chart. And then changing the ending to "-ide" again. Now, like I said earlier, we can also have 3 elements. So if for the last one, the H2O, if we want to say add an F4 on the end, again, keeping that order on the periodic table from left to right, we bring the 2 down for dihydrogen. Mono, there's a little hidden 1 right there. Monoxide. And then the 4, we take the tetra from the chart. Making the final answer to this question, a lengthy one, but dihydrogen monoxide tetrafluoride.
And the last topic is hydrocarbons. So hydrocarbons are compounds composed of carbon and hydrogen. There are 2 main types of hydrocarbons, which the 2 main types are saturated and unsaturated. So saturated hydrocarbons only have 1 bond for carbons, and these are called alkanes. Then there's unsaturated hydrocarbons, which have multiple bonds, which are called alkenes and alkynes. So if you look here, you'll see it's saturated because first there's propane, so there's only 1 bond because it ends in ane. So you're going to have a single bond there, and yeah. And then for unsaturated, you're going to see that ends with ENE, or ENE, and it's going to be unsaturated because it's a multiple bond. Oh, yeah. Okay, so next, to name hydrocarbons, you got to use the Greek prefix, which represents the number of carbon atoms. So it's basically the same it's the same prefixes as any other thing, except for the first 4. So instead of doing Mono, it's going to be meth for 1. Instead of doing di for 2, it's going to be eth. Instead of doing tri for 3, it's going to be prop with a long O. And then instead of doing tetra for 4, it's going to be bute with a long U. So the suffix tells you if it's unsaturated or saturated hydrocarbon. So the suffix are alkanes, which means a single bond, and it ends with A and E, so ane. Then you have the alkenes, which are double bond, which end in E and E, which is ene. And then alkynes, which show a triple bond, which ends in Y and E, also known as ine. And by the way, there's no such thing as methene or methine because there's only one bond because it's one carbon atom. Okay, so for some example problems here, I'll start with the alkane section. So I'll do the first one. So we're gonna have methane. So methane. First, look at prefix, underline that. That's gonna be 1 according to this chart, and it's gonna be saturated because it ends with ane. So that means there's gonna be 1 bond. So when you're writing this out, you're gonna write 1 carbon atom right there. And because it's carbon, you have to get it to equal 4 bonds. So then you're going to have 1, 2, 3, 4 hydrogens to complete this, or this atom, or this compound. And for the next one, you're going to have ethane. So you underline prefix here. You see that means 2 according to the chart. It's also going to be saturated. It's also going to be a single bond. So F, there's 2 carbon atoms here. It's going to be a single bond. There's only 1 single bond. And then you have to get this to equal 4. So you're going to add 1, 2, 3 more hydrogens, and 1, 2, 3 more hydrogens there. Moving on to unsaturated, we're going to have the alkenes. So starting with ethene, because methane doesn't exist. So you have F. Underline F, and you're going to see that it means 2. Ene, it's going to be unsaturated. So here you're going to draw 2 carbon atoms, and then because it's 1 double bond, you're going to have a double bond between these 2, and then you got to get it to equal 4. So you're going to add 2 more hydrogens each side, because this represents 2, 3, 4, 2, 3, 4. Next one, we do propene. So you're going to underline that, and you're going to see that prop equals 3, and this is obviously alkene. So you're going to have 3 carbon atoms. There's going to be 1 double bond, and then there's going to be 1 more single bond. And then you have to get this to equal 4, so you're going to write 2 more bonds here, 1 here, and then 1 more here, to all equal 4. Or 2 more, 3 more here, and that equals 4. Then moving on to the ines, the alkynes, you're going to have ethyne. So, that's 2. So you're going to have 2 carbon atoms, and alkynes have a triple bond, so there's 1 triple bond here. In order to get it to equal 4, it's just 1 more bond on each side. Moving on to the last example, I'm going to do butane. So bute. You're going to look at your chart and see that this equals 3. So you're going to have 3 carbon atoms. You're going to have 1 triple bond, and this other one's going to be a single bond. So to get this to equal 4, it's going to be 1 bond here for hydrogen. This is going to be, this is already 4, so you don't need to put another bond here. Then you're going to have 3 more here, and that's butane. And that's nomenclature.